So the second thing is it passes through a point and it is perpendicular to the given vector or given direction. Now suppose if I take point P as x1, y1, z1, which is the foot of the perpendicular. ON and NP are perpendicular to each other and R is the position vector of the point P. We know that the direction ratios or the direction cosines of the lines are proportional. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we are going to discuss about the equations of plane. In our previous session, we have discussed about the equations of line, angle between lines in three-dimensional plane. And here we are discussing about the equations of plane in three-dimensional space. Now, here we have how we will determine the plane. A plane is uniquely determined if any one of the following is known. The first one, either there should be a normal to the plane and its distance from the origin is given. That is, whenever there is any plane, there must exist any normal from the origin to the plane whose distance is given, and that can be taken as equation of a plane in normal form. So the second thing is it passes through a point and it is perpendicular to the given vector or given direction. The third one is it passes through any non-collinear points. That means if you have any non-collinear point, the plane has to be surrounded between the non-collinear point. So these are the conditions to determine that there is a plane. So let's study one of the equation of a plane in normal form. Equation of a plane in normal form. So here consider a plane here. So here I have taken a triangular plane. So let ON be the normal to the plane from the origin. That means you have a plane here. I am writing a normal to the plane which is from the origin. And let me take a point to P whose coordinates are x, y, z such that the line draw from P to the normal ON will be perpendicular. That is, we can clearly say ON and NP are perpendicular to each other and R is the position vector of the point P. Now, from the diagram here, let us consider ON drawn from origin to the plane which is a normal to the vector. So, thus, whose distance is D. Next, we have here a line NP which is perpendicular to ON. Now, since we are talking about the line here, in three-dimensional, we consider it as a vector. Now, let us consider N cap here. So, where N cap is the unit vector perpendicular to the plane along the direction of the normal ON. Now, thus we can write ON as D into N cap. And I already said let P be any arbitrary point such that the distance PN is perpendicular to ON. So, we have here ON perpendicular to NP. Now, clearly observe here, when two vectors are perpendicular, their dot product is 0. So, thus I can write it as NP dot ON is equal to 0. NP can be written as OP minus ON dot ON is equal to 0. Now, what is OP? It's a position vector R. So, vector R minus ON I have taken as D N cap dot D N cap is equal to 0. So, next here I'll write vector R minus D into N cap dot N cap is equal to 0. Since distance can't be equal to 0 here, I can equate this thing. Now multiply the dot product. We have R dot N cap minus D into N cap dot N cap is equal to 0. So we know that when you have the dot product of the same component, its value is 1. That is, N dot N is nothing but a unit vector which will become their magnitude 1 into 1, which is value is 1. So thus we have R dot n cap minus d is equal to 0, or r dot n cap is equal to d. So this is the vector form of the equation of a plane in normal form. Again, when you consider the point P as, or vector OP, which is considered as vector R, as xi plus yj plus zk, and n cap is a unit vector whose direction cosines are given, then I can write Li plus mj plus nk. Then we have here dot product of r dot n cap, so which becomes x into L, or I can write L into x plus m into y plus n into z is equal to d. So this is the Cartesian form of the equation of a plane in normal form. So thus here, whatever the diagram is given, you have to write the description, derive the equation in both vector form as well as the Cartesian form. Again, this is also one of the important question for 5 marks. So from 3-dimensional geometry, you will have one 5-mark question for the derivation. It may be derivation of lines in where it is passes through the point as well as parallel to the vector, or equation passing through 2 given points, and the other 2 is equation of plane in normal form, and one more you have equation of a plane passing through the point and given perpendicular to the given direction. So next we have find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector 3i plus 5j minus 6k. So clearly the distance is given, that is d is given, and the vector is given but not the unit vector. N cap is nothing but the unit vector, but here vector n is given. So d is given as 7 unit, vector n is given, that is the normal vector 3i plus 5j minus 6k. Now let us find out n cap. We know that n cap is vector n divided by magnitude of vector n. So thus we have 3i plus 5j minus 6k divided by magnitude of the vector is 3 square 9, 5 square 25, 6 square 36. So square root. So we have here 1 by root 70 into 3i plus 5j minus 6k. So now we know the vector form of the equation of a plane, that is r dot n cap is equal to d. So thus r is nothing but xi plus yj plus nk dot, and here we have 1 by root 70 3i plus 5j minus 6k is equal to 7. So this is the vector form of the given plane. Next one, find the vector equation of the plane which is at a distance of 6 divided by root 29 from the origin, and it is normal to the vector from the origin 2i minus 3j plus 4k. Also find its Cartesian form. First we will find the vector form of the equation. So now here we have the distance as 6 divided by root 29. Now let us find n cap, because vector n is given. So vector n is given as 2i minus 3j plus 4k. So thus we have n cap. Let us calculate n cap. N cap is 2i minus 3j plus 4k over magnitude of vector n, that is 2 square 4 plus 9 plus 16, which is equal to root 29. So we can write it as 2i minus 3j plus 4k divided by root 29. So thus we have r dot n cap is equal to d. So I can just write r as it is. Write down n cap, that is 2i minus 3j plus 4k divided by root 29 is equal to d. Now we can write the Cartesian form. Since we know the direction cosines of the unit vector. So the direction cosines is nothing but the coefficients of the components. 2 by root 29 minus 3 by root 29 and 4 by root 29 are LMN, and we know the vector R as x, y, z. So therefore, what is the Cartesian form? Now we know that Cartesian form is Lx plus My plus Nz is equal to D. Now we know that here L is 2 by root 29. So it is 2 by root 29 x. Next M is minus 3 by root 29 minus 3 by root 29 y, and N is 4 by root 29. So plus 4 by root 29 z is equal to D. So we have distance D as 6 by root 29. So here the value of D can be written as 6 by root 29 now. Now you can multiply root 29 on both sides, then the equation becomes 2x minus 3y plus 4z is equal to 6. So this is the equation of the plane in Cartesian form. Next, find the coordinates of the foot of the perpendicular drawn from the origin to the plane 2x minus 3y plus 4z minus 6 is equal to 0. So here the Cartesian form of the equation of the plane is given, that is in the form of this. So we have this in the form of Lx plus My plus Nz. Now let us divide it by the magnitude of the vector 2x minus 3y plus 4 square, or we can take 2, 3, 4. So let's take 2 square is 4, 3 square is 9, 4 square is 16. So we have this as root 29. Now divide whole equation by root 29. So we have 2 divided by root 29x minus 3 divided by root 29y plus 4 divided by root 29 z is equal to 6 divided by root 29. So therefore, the direction ratios or the direction cosines, we can say the DCs of line is 2 by root 29, comma, minus 3 by root 29, comma, 4 divided by root 29. Now suppose if I take point P as x1, comma, y1, comma, z1, which is the foot of the perpendicular. So suppose if I say here we have any plane here and any perpendicular line is passing, and if I say this as a point P, the foot of the perpendicular, we know that the direction ratios or the direction cosines of the lines are proportional. So therefore here the direction cosines becomes x1 divided by 2 by root 29, which is equal to y1 divided by minus 3 by root 29, which is equal to z1 divided by 4 divided by root 29 is equal to k. And when you solve this equation, you will get x1 as 2k by root 29 and y1 as minus 3k divided by root 29 and z1 as 4k divided by root 29. So this is what you will get. Now substituting x1, y1, z1 value in the given equation. Let me take this as equation 1, and now let us substitute x1, y1, z1 value in this equation, that is 2x minus 3y plus 4z is equal to 6. So we have here 2. In the place of x, you can substitute x1. So we get 2k divided by root 29. Next we have minus 3y. So minus 3y means we have minus 3k divided by root 29 plus 4z. So plus 4z1 we can take it as 4k divided by root 29 is equal to 6. So this is the equation we have. Next we will multiply this. This is 4k. Since the denominator is same, just add the numerator. Minus into minus plus 9k plus 16k whole divided by root 29 is equal to 6. So 4 plus 9 plus 16 becomes 29k. 29k is equal to 6 root 29. We know that 29 can be written as root 29 by root 29. That is root 29 whole square. We can cancel it. So we will get the value of k as root 29. Now you got the value of k as 6 over root 29. Substitute here. Let me take this as equation 2. We can find the foot of the perpendicular. So x1. So when you substitute, k is equal to 6 over root 9. So x1 is equal to 2 into 6 over root 29 divided by root 29. So here this becomes 12 by 29. Next we will calculate y1. y1 is minus 3 6 over root 29 divided by root 29. So we will get minus 18 by 29. Similarly, we will calculate z1 here. So z1 is 4 and k is 6 over root 29 divided by root 29, which is 4 6 are 24 divided by 29. So therefore, x1, y1, z1, which is nothing but the foot of the perpendicular, or the coordinates of the foot of the perpendicular, is 12 by 29, minus 18 by 29, 24 by 29. So this is the coordinate of the foot of the perpendicular. Next, find the coordinates of the foot of the perpendicular drawn from the origin to the plane. 2x plus 3y plus 4z minus 12 is equal to 0. Again, let us write this equation in the normal form. So let us divide it by 2 square plus 3 square plus 4 square. So 2 square is 4, 3 square is 9, 4 square is 16. Again it is root 29. So divide the whole equation by root 29. So then we will get a unit vector form, that is in the normal form. So let me take this as equation 1. Now we have the equation of a plane in normal form. So this represents the direction cosines of a line. So therefore the DCs are 2 by root 29, 3 by root 29, 4 by root 29. Again, let there be any plane. So here, and let this be a perpendicular, and P is the foot of the perpendicular. This is the foot of the perpendicular on the plane. So let x1, y1, z1 denotes the plane. We know that the normal, the direction, or the normal means which is perpendicular to the plane. The lines DCs are 2 by root 29, 3 by root 29, 4 by root 29. And the foot of the perpendicular means the point lies on the same line. Thus we can say the direction ratios and cosines of the line are proportional to each other. If I take point P coordinates as x1, y1, z1, then I can write the ratios of x1, y1, z1 as x1 divided by 2 over root 29 is equal to y1 divided by 3 over root 29, and z1 is equal to 4 over root 29 is equal to some k. So from this I can write x1 in terms of k as x1 is equal to 2 by root 29 or 2k, and y1 is equal to 3k by root 29, and z1 is equal to 4k by root 29. Let me take this as equation 2. Now substitute 2 in equation 1. Then we have 2 into 2k by root 29 plus 3 into 3k by root 29 plus 4 into 4k by root 29 is equal to 12. So when you add all this, you will get here 4k plus 9k plus 16k is equal to 12 root 29. So here again it is 29k is equal to 12 root 29, or I can write k is equal to 12 divided by root 29. Now we know the value of k, substitute back to the equation 2. So then I will get x1 as 2k over root 29. So 12 2s are 24 by 29. And y1 as 3k over root 29. So we have 12 3s are 36 by 29. And z1 as 4k. So 48 by 29. So thus we have x1, y1, z1 as 24 by 29, 36 by 29, 48 by 29. So this is the coordinates of the foot of the perpendicular. Next, determine the direction cosines of the normal to the plane and the distance from the origin. So we have here in the Cartesian form, that is x plus y plus z is equal to 1. Again, to convert this in the normal form, I need the values of the components of x, y, z. So here we have 1, 1, 1. That is square root of 1, 1, 1. 1 plus 1 plus 1, which is equal to root 3. So divide the equation by root 3. Then it becomes 1 by root 3x plus 1 by root 3y plus 1 by root 3z is equal to 1 by root 3. Now this is in the form of Lx plus my plus nz is equal to distance d. So therefore Lmn or the direction cosines. The direction cosines are 1 by root 3, 1 by root 3, 1 by root 3, and distance is 1 by root 3 units. So the given equation has to be converted into normal form, so that using the Cartesian form of Lx plus my plus nz is equal to d, we can write the direction cosines of the normal to the plane as well as the distance of the normal to the plane. So in today's session, we have learnt the equation of a plane in normal form. That is, in vector form, we write it as r dot n cap is equal to d, where d is the length of the perpendicular to the plane, that is the normal, and n cap is the unit vector in the direction of the normal, which is perpendicular to the plane, and the Cartesian form is Lx plus my plus nz is equal to d. So again, it's a 5 marks important derivation for the point of examination. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.